Yeah. So we are discussing about solutions of liquids in liquids. In that first example is what? Benzene liquid and carbon tetrachloride liquid. So benzene formula what? C6H6. The benzene liquid dissolved in carbon tetrachloride CCl4. CCl4. So here two liquids are mixed here. That's why it is what now here? Solution of what? Liquid in liquid. Liquid in liquid. Here one liquid acts as what? Whichever is less in quantity acts as what? Solute. The other liquid which is in more quantity is called solvent. So solvent is liquid. Solute also is liquid. So solution of liquid in liquid type. First example is what here? Benzene and carbon tetrachloride. So here when you mix benzene liquid with carbon tetrachloride CCl4, no evolution of heat occurs. Otherwise, no absorption of heat occurs. That means what? No absorption of heat, no evolution of heat. Evolution means what here? Release. There is no release of heat energy. And also, there is no absorption of heat energy. Whenever we mix what? Benzene liquid with carbon tetrachloride liquid. It is one type of liquid where the solution is formed by dissolving one liquid in other liquid, but there is no evolution of heat and also there is no absorption of heat. That condition is taken. Example for this type of solution is what? The solution of benzene liquid in carbon tetrachloride liquid. Here benzene is liquid and carbon tetrachloride also is liquid. One liquid is dissolved in other liquid and no amount of heat energy released here. So here neither exothermic nor endothermic we can say. When we mix benzene with carbon tetrachloride liquid, we don't get any heat energy released and also heat energy is not absorbed. That means what we can say, as energy is not released, it is not exothermic dissolution. And also when there is no absorption of heat energy, it is called endothermic absorption, endothermic dissolution, but it is neither exothermic nor endothermic dissolution. That's why we say here delta H of solution, delta H of solution, enthalpy of solution, enthalpy of solution is zero, neither positive nor negative. Okay, delta H solution means what? Enthalpy of solution of benzene in carbon tetrachloride solution is equal to zero. That means no negative charge, no minus, no positive charge here. If delta H is negative, exothermic. If delta H is positive, endothermic. But it is neither positive nor negative. That's why we say delta H solution is zero for this type of solution. And second type of solution is that the solution of acetone liquid in water liquid. When you dissolve acetone in water, acetone is liquid here, water is also liquid. So liquid is dissolved in another liquid. If acetone is taken small quantity, it is called solute, and water is taken large quantity, it is called solvent. So solute liquid is dissolved in liquid solvent. When you mix acetone with water, we get some solution. That solution will release what? Some amount of heat energy. When the formation of solution takes place here from acetone and water, we get some heat energy released. Evolution means what? Here release. So release of heat energy takes place. Release of heat energy means exo or endo? Exothermic dissolution. Exothermic dissolution we say here. So when acetone is dissolved in water, when acetone is dissolved in water, some amount of heat energy is released. As evolution of heat is taking place, this type of dissolution comes under exothermic dissolution. What we say? Exothermic dissolution takes place. Exothermic means delta H value negative or positive. Delta H solution, enthalpy of solution is what? Negative. Delta H solution means what? Enthalpy of solution. This enthalpy of solution value will be negative here. That's why it is what now? Exothermic solution formed here. Okay. And now third type of solution formed is ethyl alcohol liquid is dissolved in water liquid. Okay, ethyl alcohol is liquid, water is liquid. So when ethyl alcohol is dissolved in water, some amount of heat energy is absorbed. Some amount of heat energy is absorbed. Here some amount of energy is released. Evolution means release. Absorption means absorption. Okay, so some amount of heat energy is absorbed when we dissolve ethyl alcohol in water. Okay, so as absorption of heat is taking place, this is called what now? Endothermic dissolution. What we say? endothermic dissolution occurs here. So due to endothermic dissolution, what happens? The amount of energy will be, heat energy will be absorbed from surroundings. From surroundings, some amount of heat energy is absorbed. That's why this type of what here enthalpy is called. What enthalpy of solution is negative. Whenever here absorption is endothermic means delta H value should be what now? Delta H solution should be positive. So whenever delta H solution, enthalpy of solution is positive, the type of dissolution is called what? Endothermic dissolution. Why we have taken delta H positive here? Absorption is going on. Why we have taken delta H negative here? Heat energy is released here. And why here 0 taken? 0 means what? No negative, no positive value here. That means what? Delta H is? Delta H is 0. Neither negative nor positive. So this type of dissolution is not involved with absorption of heat or release of heat. First case. Second case, release of heat energy going on when solution is formed. And third case, absorption of heat energy is going on when solution is formed. So these were 3 types of solutions we can classify. Which type of solutions we are discussing here? Solutions of liquids in liquids. The solutions of what in what? Liquids in liquids. Solutions of liquids in liquids we are discussing here. Right, ma'am? So in this case, 3 types of solutions. In first case, no heat energy is released and no heat energy is absorbed. Second case, heat energy is released. And third case, heat energy is absorbed. Liquid systems means liquid solutions, meaning systems meaning what here? Solutions. Whenever solution is formed by dissolving one liquid in other liquid, that is called liquid system or liquid solution. Now first type here, liquids that are completely miscible. Miscible means what? Can be mixed with one another. Completely miscible means thoroughly mixed. Completely miscible meaning what, ma? Thoroughly mixed. Thoroughly mixed. So when you mix 2 liquids, the 2 liquids will be thoroughly mixed. It is called what now here? The liquids, okay, that are completely miscible with each other, thoroughly mixed with each other. So examples of this type, what here? Examples of this type of miscible liquids: benzene and toluene. Benzene formula we have taken C6H6, C6H6 benzene, and toluene C6H5 bond CH3. C6H5 bond CH3 means methyl. CH3 group is methyl. When methyl group is substituted in benzene ring, it is called methyl benzene. Methyl benzene is called what? Toluene. In benzene C6H6 there na, one hydrogen is replaced by what? One methyl group, CH3 group. Then we get C6H5 bond CH3. Okay, this is called methyl benzene. Methyl benzene is called what? Toluene. Okay, benzene and toluene, when you mix these 2 liquids, a benzene is liquid, toluene also liquid. When these 2 liquids are mixed, they will be thoroughly mixed with each other. That's why they are miscible liquids, we say. Benzene and toluene are miscible liquids. First example. It is what now here? First example. And second example is what here? Ethyl alcohol. Ethyl alcohol formula what? C2H5OH. Ethyl alcohol formula C2H5OH. Ethyl alcohol and water. Water we know H2O formula. So when alcohol is mixed with water, that will be, both liquids will be thoroughly mixed with each other or not? They are thoroughly mixed with each other. So ethyl alcohol mixed with water, okay, will form a solution of liquid in liquid. Okay, ethyl alcohol and water. Okay, this is what now here example, second example for miscible liquids. And third example for miscible liquids, carbon tetrachloride. Already we have discussed the formula CCl4. CCl4, carbon tetrachloride and benzene, C6H6. So carbon tetrachloride and benzene. When benzene is mixed with carbon tetrachloride, these 2 liquids are thoroughly mixed. Now carbon tetrachloride is liquid, benzene is liquid. Okay, so when this liquid, carbon tetrachloride liquid, is dissolved in benzene liquid, we get what now here? A solution of liquid in liquid. That is called liquid system. So in first case, what we have taken? Miscible liquids. Miscible liquids means what? Completely miscible, thoroughly mixed with each other. Example what? Benzene and toluene. Second example, ethyl alcohol and water, and benzene carbon tetrachloride. So benzene carbon tetrachloride one pair, benzene and toluene one pair, and third pair example what? Ethyl alcohol and water. Ethyl alcohol formula C2H5OH. If you don't know toluene formula, you please write down toluene name and toluene formula. If you don't know ethyl alcohol formula, write ethyl alcohol name and C2H5OH formula. Whatever you do not know, that you write down in notebook. Okay. Now next, liquids that are partially means incompletely, partially miscible means incompletely mixed. Partially miscible meaning what? They are miscible but to very less extent, not completely mixed, not thoroughly mixed. Partially means incompletely. So liquids that are partially miscible will come under second type of liquid systems. In this example, check it here. Example 1, ether and water. First example is what? Ether and water. Ether means here ether. Okay, here ether will be of different types. Suppose you take CH3 bond O bond CH3. It is dimethyl ether. Here CH3 methyl group, CH3 methyl group. Here bond O bond is called ether. This bond O bond is called ether. And here CH3 bond O bond CH3 is called dimethyl. How many methyl groups in this formula? 2 methyl groups. So dimethyl ether is an example of ether. Like this, if you take ethyl C2H5 left side, C2H5 right side, diethyl we say. C2H5 bond O bond C2H5 is called diethyl ether. Here we have taken CH3 methyl groups. That's why it is called dimethyl ether. So dimethyl ether and water will form which type of liquids? Incompletely or completely? Incompletely mixed, partially mixed. Okay. Next, second example. Second example, you check it here. Phenol and water. Phenol and water. Phenol formula, you check it. C6H5 bond OH. Phenol formula what? C6H5 bond OH. Now benzene formula is there na? C6H6 formula. In benzene, one hydrogen atom is replaced by OH group. This bond OH group is called alcohol group. Bond OH group is called what? Alcohol group. Here in ethyl alcohol also we have OH na? Ethyl alcohol also OH group is there. The OH group is called alcohol group. Alcohol functional group, you remember. What is this OH called? Alcohol functional group. Okay. Now C6H5 bond OH is called phenol. So phenol and water. When you dissolve phenol in water, we get what now? The solution of completely miscible liquids or incompletely miscible liquids. The solution of incompletely miscible liquids we get. Solution of incompletely miscible liquids. Now phenol is not completely mixed with water. Okay. Phenol and water are immiscible or partially miscible. Partially miscible. Immiscible means completely not miscible, but partially miscible means mixed. They can be mixed to some extent. So ether and water, phenol and water, ether and water and phenol and water. These two are examples of what? Which type of liquid systems? The liquids which are partially miscible. Partially miscible. And next one here, nicotine and water. Third example is what here? Nicotine and water. So nicotine is present in what? Tobacco. In tobacco, what is there? Nicotine is present in cigarettes. Okay. So that nicotine in water, nicotine and water. When dissolve nicotine in water, we get what now here? In these two are what now? Incompletely miscible. So nicotine liquid is dissolved in water liquid. Suppose when nicotine liquid is dissolved in water, okay, these two are called what now? Partially miscible liquids, incompletely miscible liquids. So examples of partially miscible liquids, tell me. Nicotine and water, phenol and water, ether and water. So what is common here? Water is common in three examples. Ether and water, phenol and water, nicotine and water. Okay. So if you want to clean the bathroom floor, we add what? Phenol to water. It's not phenyl. What is that? Phenol. So phenol is added to water. This phenol and water together called what now? These two liquids are what? partially miscible liquids. Next, liquids that are practically immiscible. Practically, not partially. Practically immiscible. Immiscible meaning what? Completely not miscible. Not mixed. Not at all mixed. Not at all mixed. When you mix two liquids, the two liquids are not at all mixed with each other. That are called practically immiscible liquids. So liquids that are practically immiscible. Immiscible meaning what? Not mixed. Not mixed with each other. So first kind is what? Tell me. First kind is what? Miscible liquids. Miscible liquids. Second type is what? Here first type is miscible liquids. Second type is what? Partially miscible, means incompletely miscible. And third type is what? Practically immiscible liquids, means they are not at all mixed with each other. Examples of this kind, you check it. First example is what? Benzene and water. Benzene and water. Okay, phenol and water practically means for partially immiscible or partially miscible. Phenol and water partially mixed. But benzene and water, immiscible liquids. Immiscible liquids means one cannot be mixed with other liquid. So benzene liquid and water liquid. These two are practically immiscible with each other. And second example of this kind, carbon tetrachloride and water. Second example is what? Carbon tetrachloride and water. Means CCl4 liquid and water. CCl4 liquid and liquid water. These two also immiscible liquids. Immiscible meaning what? They are not mixed with each other. Carbon tetrachloride and water. Okay, but carbon tetrachloride benzene, and benzene are miscible, completely miscible. Carbon tetrachloride benzene are completely miscible. But carbon tetrachloride and water incomplete, means were not at all mixed. They are immiscible. Tell me difference why? Why these two are taken like this here? Why carbon tetrachloride is dissolved in benzene? Why not carbon tetrachloride dissolved in water? The reason is that here benzene is what? Benzene is non-polar solvent. Non-polar solvent. But water is polar solvent. Water is polar solvent. Water is example of polar solvent. Benzene is an example of non-polar solvent. Like dissolves like, do you remember statement? Like dissolves like means what? Non-polar substances are dissolved in non-polar solvents, and polar substances are dissolved in polar solvents. Here carbon tetrachloride, CCl4. CCl4. CCl4 is what? Non-polar. It is non-polar substance. As CCl4 is non-polar substance, it is miscible only with benzene, non-polar liquid. But water is polar liquid, na? Polar solvent. Na? That's why carbon tetrachloride is not soluble in water, immiscible in water. That point keep in mind. And third example is what now here? Benzene and alcohol. Benzene formula C6H6. Alcohol means you always take ethyl alcohol first. C2H5OH. Okay, what is common alcohol? Common alcohol is what? Ethyl alcohol, C2H5OH. This ethyl alcohol is present in all beverages. Beverages such as what? Brandy, whiskey, rum. In all these cases, what will be there? Alcohol will be present. The alcohol is mixed with water in that. Alcohol and water, miscible liquids, immiscible liquids. Alcohol and water, miscible liquids. They are thoroughly mixed with each other. But benzene and ethyl alcohol, immiscible. Benzene and water also immiscible. Benzene water immiscible. And benzene ethyl alcohol immiscible. But ethyl alcohol and water are miscible, are thoroughly mixed. Okay. So now remember that why ethyl alcohol is dissolved in water. Why ethyl alcohol? See here, C2H5OH liquid. Okay, plus water liquid. So they are miscible. Why they are miscible here? Now see, suppose if we take this one, ethyl alcohol, non-polar. Ethyl alcohol is one example of non-polar substance. Ethyl alcohol is example of what? Non-polar. Water is what? Polar. Water is polar. But non-polar should not be dissolved in water generally. Non-polar should not be dissolved in polar water. But why ethyl alcohol is soluble in water? The reason is that between hydrogen and whatever oxygen, between hydrogen and oxygen, there will be hydrogen bonding between hydrogen atom of water and oxygen atom of ethyl alcohol. Between oxygen and hydrogen, what will be there? Hydrogen bonding will be there. Because of hydrogen bonding, the ethyl alcohol is soluble in water. Don't think that ethyl alcohol is polar substance. Ethyl alcohol is non-polar substance only. But this ethyl alcohol is soluble in water due to formation of which bonding? Hydrogen bonding, H bonding. H bonding meaning what? Hydrogen bonding. So there will be hydrogen bonding formation between ethyl alcohol and water. That's why ethyl alcohol is thoroughly mixed with water. This point keep in mind. And why CCl4 is not soluble in water? Why CCl4 plus water immiscible? The reason is that CCl4 in CCl4 and water, hydrogen and Cl cannot form hydrogen bond between hydrogen atom of hydrogen between hydrogen atom of water and Cl of chlorine. Between Cl of chlorine and hydrogen of water, hydrogen bonding cannot be formed. Hydrogen bonding cannot be developed. That's why the CCl4 cannot be soluble in water. Did you all understand concept now here? Okay. Next, miscible liquids form three types of solutions. Miscible liquids means what? One is thoroughly mixed with other. One liquid is completely mixed with other liquid is called miscible liquid. So the miscible liquids can be divided into how many types? Three types. Okay, miscible means what? Completely miscible. The miscible liquids form three types of solutions, which can be ideal solutions or non-ideal solutions. Ideal solutions and non-ideal solutions. Again, this non-ideal will be two types. Non-ideal will be two types. How many types of non-ideal? Two types. So non-ideal solutions with positive deviation, and non-ideal solutions with negative deviation. We'll discuss about the positive deviation and negative deviation later. But remember, for time being, that non-ideal solutions will be of two types: positive deviation and negative deviation. Means non-ideal with positive deviation, non-ideal solutions with negative deviation, along with ideal solutions. So totally how many types of solutions here? Three types of solutions. Miscible liquids. The solutions of miscible liquids will be of three types. One is non-ideal, one is ideal solution. Second one, non-ideal solution with positive deviation, and third one, non-ideal solution with negative deviation. That one keep in mind, three types. So what are the examples of miscible liquids? Tell me. Miscible liquids examples: benzene and toluene. Benzene, toluene. Second example, ethyl alcohol water. Ethyl alcohol water. Carbon tetrachloride benzene. Benzene, carbon tetrachloride, benzene, toluene. Miscible. Ethyl alcohol and water. Miscible. Okay. So three types of miscible liquids will be there. First one is what now here? Ideal solution. First one is what? Ideal solution. Now remember that an ideal solution is one in which the molecules attract one another. The molecules of two liquids attract one another with equal force, irrespective of their nature. Irrespective of the nature of molecules, any two molecules will be attracting, okay, with same force. Means between any two molecules in the ideal solutions, there will be equal force of attraction. That means what? Between solute and solute molecule, and between solvent and solvent molecules. Otherwise, between solute molecule and solvent molecule, okay, there will be equal force. Between solute, x newtons. Between solvent, x newtons force. Between solute and solvent also, x newtons. Same force, equal force will be existing between any two molecules in the ideal solutions, irrespective of what? Irrespective of their nature. Thus, A solution composed of two components means two liquids. A solution composed of two components, A and B. Two components means what? Two liquids here. Two liquids. Two components means two liquids here. Now, when solution is formed by two components, it is called binary solution. This type of solution is called what? Binary solution. So, binary solution which is composed of two components, A and B. A is one component, B is one component. In general, we take A as what? Solvent. In general, A is taken as solvent, B is taken as what? Solute. Need not to take like this. Need not to take always A solvent, but generally we take what? A as solvent, B as what? Solute. Both are liquids. Now the binary solution which is composed of two components, that is two liquids, A liquid and B liquid, will be an ideal one if the forces between A and A, B and B should be same as what? A and B. Between A and B also same should be there here. So AA interactions must be equal to what? BB interactions. BB interactions. Attractions only. Interactions meaning what? Attractions. So AA interactions must be equal to BB interactions. Then that solution formed is called what? Ideal solution. Now the liquid A, liquid B can form what? Ideal solution. When you mix liquid A and liquid B, it will give what? Ideal solution. If condition what now here? If A and A interactions are same as of B and B interactions, means the force of attraction between A and A must be equal with the force of attraction between B and B. If you take small quantity of liquid A, many molecules will be there in liquid A molecules. Millions of liquid A molecules will be there in small quantity of liquid A. In small quantity of liquid B also, there will be large number of B molecules. Between A and A, whatever the attraction force is there, the same magnitude of attraction must be there between B and B. In that condition, when you mix A liquid and B liquid, we get ideal solution. So an ideal solution A and B. Okay. So A and B, A and A and B and B should be same. Okay, an ideal solution, A and A interactions must be equal with B and B. Okay, when these two attractions are same, the solution formed will be ideal solution. So an ideal solution possesses the following characteristics. When ideal solution is formed by mixing liquid A and liquid B, okay, that ideal solution formed will have the following characteristic properties. The first characteristic of ideal solution. We are studying about what now? Characteristics of ideal solutions. First characteristic property is that volume change of mixing should be zero. Volume change of mixing should be zero means, suppose you take here 10 ml liquid A plus 10 ml liquid B. Liquid A 10 ml, liquid B 10 ml we have taken. Now the solution formed is exactly 20 ml. 20 ml solution is formed here. 20 ml solution. Which solution? Ideal solution. 20 ml ideal solution is formed here. Now, if the solution volume is 20 ml and the total volume of two components also 20. Now, total volume of two components how much? 20. The total volume of solution formed how much? 20. Now, 20 minus 20 how much? 0. The solution, the volume of solution 20 minus the total volume of two components 10 plus 10, 20. Then we get what now here? Delta V mixing. Delta V mixing is equal to 0. Delta V mixing is equal to 0. Why? 20 ml minus 20 ml. Now initially, how many ml we have taken? 10 ml plus 10 ml. Finally, how many ml formed? 20. So 20 minus 20, how much? 0. Like this, delta V mixing must be 0 when ideal solution is formed. That's what we say, volume change. Delta V means what? Final volume minus initial volume. So V final minus V initial must be 0. That is, volume of solvent plus volume of solute must be equal to volume of solution formed. Here 20 ml of solution is formed. when you mix 10 ml plus 10 ml. That's why it is delta V mixing is equal to 0 for formation of ideal solutions. And second characteristic property of ideal solution is that heat change. Heat change means enthalpy change. In the place of heat, what we can use? Word enthalpy. Enthalpy change. Enthalpy change, otherwise heat change. Enthalpy change, otherwise what we say? Heat change. The enthalpy change of mixing should be 0. The enthalpy change, the total heat change, the final heat minus initial heat content. The final heat content of the system minus initial heat content of the system must be equal to 0. Here delta H mixing we read. What we read here? Delta H mixing is equal to 0. That means enthalpy change must be equal to 0. The heat is neither absorbed nor evolved. The heat is neither absorbed nor released. Okay, delta H mixing is equal to 0. Delta H meaning what here? Delta H is equal to what? H final minus H initial. Final enthalpy of the system minus initial enthalpy of the system is equal to delta H mixing. This must be 0 here. Okay, that means whatever the total heat content of solute plus solvent, the total heat content of solute plus solvent must be equal to the heat content of solution formed, and the difference must be same. Means what? The difference must be 0. When these two final and initial values are same, the difference will be 0. That is, enthalpy of mixing will be 0 for ideal solution formation. And third characteristic property is that there should be no chemical reaction between solvent and solute, between solvent A and solute B. Between solvent A and solute B molecules, there should not be any reactions. Chemical reactions should not be there. Attractions may be present. Attractions means interactions may be present, but chemically they should not combine with each other. The solvent molecules should not be chemically reacting with solute molecules. So these conditions we must understand. Okay, so these three are what now characteristic properties of what? Formation of ideal solutions. Is that clear, ma? So it's about what now here, the formation of ideal solutions. So about ideal solutions and ideal non-ideal solutions with positive deviation and non-ideal solutions with negative deviation. These all we are going to discuss in the next class. Okay, ma? Bye. Take care. Good day.